Hello and welcome to AIoT Hub. Paul's on another call, so just me hosting today. We're delighted to have Nikos Delis here, originally from Greece, but now in Sweden. Tell us about yourself, Nikos. Who you working for and what took you all the way up to Sweden?
Yeah, thank you. Yeah, I've been living in Sweden for 13 years now. Like I moved here directly after my studies and my military obligation. Like I think I was released on a Friday and I flew on Sunday, so pretty pretty quick there. No, I worked my whole career here in Sweden. I started in Stockholm and then I moved to Malmö, the third largest city of Sweden in the southern part of the country, right next to Copenhagen. Yeah, I have worked for a number of organizations, everything from product companies to consultancies, and since the summer of 2024, I have been doing some freelance work. And I work with mostly with large organizations such as IKEA and now for Swedish Match. So yeah, that's me. In my free time, I'm doing some community work for Microsoft Azure. I became an MVP also last November, so it goes very well.
Yeah, it sounds like you've got a good community going on up there in Sweden, like we do in the UK. Lots of technical meetups. Tell us
Yeah, we
about
have a
that.
fantastic group. Yeah, we together with four other excellent friends of mine, we are running Azure Skåne, which is the local meetup community group that we're running here in my city in Malmö. And we're having meetings like every month, approximately, sometimes even more often than that. We're talking about Azure and we're talking about other technology stuff that goes around Microsoft Azure. A very live and vivid community. I really enjoy being there. Yeah.
Cool. I was hoping Paul would be here to tell us about next event, which is in February. So we're going to be face-to-face in Imperial College in London, my old university. So there's going to be a mixture of academic and industry luminaries speaking at that event. So hopefully he'll be available to the end of the call. So I understand there's going to be time for questions about your talk at the end. So,
Absolutely. Yes.
Nicholas, over to you.
Thank you. Okay, now today I am going to talk to you about one of my favorite subjects, which is Azure IoT and Digital Twins. IoT stands for Internet of Things. A few more words about me before starting. My name is Nikos Telis. I work as a senior software and cloud engineer. I'm a freelancer. I have a few certifications on Azure. I have a blog called ndtechnique.com. And in my blog, I write about everything that I encounter on my work life and I consider not to be common knowledge. I also have a podcast called Azure Triumphs, where I'm the host and I am interviewing various people that work with and around Microsoft Azure. And we have had two seasons of it, and we are just kickstarting the third one right now. I'm doing some community work, again, around Azure, as I mentioned earlier. And since November 2024, I am a Microsoft MVP. Now about the session itself and the agenda. I am going, or before starting, every session that I do, everything I talk about is about something that I am working with or that I did work with in the recent past. So today I am going to work to talk to you about my work with robotic arms. Believe me, it's very interesting, and I believe that you will gain quite a lot out of it. Now, first of all, I will try to explain the whole case, to explain the whole model of the company, what they are doing. Then we are going to go further and explain what I am doing for them and why I'm doing that. And of course, all this is based on Azure, so we're going to have quite a lot of that as well. Now, the company that the project was about is called Rebel Industries. Now, I'm not advertising anything. It's like a startup company in close to the middle of Sweden. I don't think we have any potential customers in the call anyway, but I just have to explain you what they do. Now, Rebel Industries provides appreciated, engaged, and effective workmates, but in real world, this means that they are like a consultancy, but instead of human consultants, they have robotic arms. So the clients can rent a robot and pay by hour or by performance or by whatever they pay the robotic arm to do. An example of such performance is random depalletizing. Now, I believe that you all have seen those big wooden pallets that are loaded with boxes and stacked on containers on the big ships. Now, as you can imagine, all those pallets go to a terminal somehow, and then someone has to unload them. Someone has to take all the packets from the pallet, put them on a band, then the band will take them long way into the premises, and then somehow a truck is going to pick the packet and deliver it to its recipient. This is pretty much what it is all about. Now, our robotic arm, which is called Clipson, by the way, manages to unload more than 600 packages per hour. This is pretty good. It's way more than a human being could do for a longer period of time. Of course, as I mentioned before, the clients are only paying for what the robot does. They don't pay for when the robot is sitting around. Then a good thing, and the reason why it's such a big of success is that the robotic arms are trained in the lab and then delivered to the client, and they can start working immediately. They don't need to spend a lot of time between the idea and the delivery of the robot. Then, of course, it is well trained, it does well on its performance, but it is also a very secure, very stable, and a very noble beast, as you will see. Now, I mentioned Clipson, and here he is. Now, except, of course, I understand that the robotic arm, this part, is what steals the show. I believe that this one weighs something around 600 kilos, so it's a pretty heavy thing. On the bottom of it, you can see a very big cement block, which makes sure that Clipson isn't going anywhere. Actually, it can go pretty much anywhere because it has wheels under that. But as you can imagine, when it's stationary, then they use brakes to stick it there, so it can't be moved. It can't be it can't injure anybody. Now, except from the robotic arm, we have an overall control system. This is a mega computer with like crazy amounts of memory and CPU power and lots of space in the disks, and all those parts you can imagine are industry level. It has a lot of sensors. It has a camera. Actually, it has many cameras, but the interesting one is the one on the top here. We can't see it on that image, but it is taking photos of the pallet real time. I believe that you will see it in a video in a while. And this is how the photos are being analyzed real time. And a sort of algorithm is indicating for Clipson where to go to pick the next pallet, and then to move it to the band, and then move home, and then again and again and again. And of course, there are some parts of the process that have to be done by the machine conductors. Those are very important parts, and there's also an emergency stop and all that stuff. And for me, the most important sensor of them all is the one that detects activity in the proximity, in the orbit of Clipson. So if a human being is closing by, maybe by accident, maybe they didn't notice this huge robot there. Maybe they just wanted to come close to see it. Then it will pretty abruptly pause whatever it's doing and start to go slower, slower, slower. Now, you might imagine that this isn't moving like that fast, but in reality, it can move really fast, and you don't want to be slapped in the head by such a heavy machine. So this sensor makes sure that whenever a human being is coming close, that it will immediately slow down, stop whatever it's doing, and never, ever, ever risk injuring someone. Now, let's see it in action. Okay, it is moving packages. Okay, let's pause it for a second. I'm sorry. Oh, I'm afraid I can't pause it. Anyway, I can talk over. Now, as you can see, those weren't moving, and this is because here in the depths we had other packages moving, creating a traffic jam. See, they stopped again. But now there is space, so it will put the packets here. And again, it picks it slowly, and it puts it very, very, very slowly down to not jeopardize breaking something inside the packet. What it does, though, again, it waits for those to move, and when it has space, now it has space, now it's putting the packets on the band. In the meanwhile, the reason why it stopped for a second there, and maybe you can see a red light flashing here, what is happening is that the camera up there is taking photos of the stack to identify the places of the new packets. It's like Tetris, but in the opposite way. We remove blocks. Again, it will put the packets on the band and then it will wait for a second. And the reason it's waiting, pump, now you see, it takes a photo, it knows where to go, it goes very fast. You see that as well. When it has no packets, it goes very fast home to save time. But when it has one, then it goes slowly, slowly, and very careful not to break anything. Mm? Maybe it's worth to mention as well that it's shutting up the packets using vacuum swamps, as you can see up here. And yeah, that's pretty much all of it. We have the motion sensor here that identifies if anybody's closing down. And yeah, that's it. So now enough about the robotic arms. As you can imagine, when working with this process for many, many hours, and when it's time for the clients to compensate Clipson for its activity, a few questions arise. For example, how many packages did we pick? How fast was the robot this day? Then some things might go wrong, and not only mechanical things, but even software things, like the hard disk might be full, or we might want to get like softer data, or we want to instruct the robots to do things. Now, the reason we communicate with the robotic arms is by events. It is all about events. And an example of those events is that something has happened, like that the robot did something, or that the robot is waiting for something. Now imagine that the waiting is an event that happens once, like now I am starting waiting, but it takes time. And then something not happening might also be an event. And that the operator did something obviously also is an event. Now, for the crew of Rebel Industries to be able to operate those robotic arms, it's not enough for the robot to be working and communicating a heartbeat like I'm alive, I'm alive, I'm alive. We need to see exactly what it is doing. And there isn't always the possibility of putting a high definition camera or something because those robotic arms might be placed in like in factories in the middle of nowhere. They might be placed in positions that there is no connectivity. All those scenarios are possible. Actually, okay, there is always connectivity, but maybe we don't have the bandwidth needed to perform like real surveillance. And now is about where I come in the picture. So when I started, what we had was that, like the robotic arm was sending messages to the mega computer that is attached on the robot. And then the people who were SSH were using SSH to connect to VPN. They were using VPN to connect to the network of the robot, and then SSH to connect to the machine. And they were manually reading those messages every time they wanted to understand what was happening. Now, what we will end up with is something like that the messages are being sent from this mega computer to Microsoft Azure, from there to our iOS data storage alternatives. They're going to be displayed with Grafana, and we also have a portal where we can do some things. Now, again, if we're talking with architectural terms, I'm sorry, here we are. What we had in the beginning was that the hardware part, the golden, the yellow rectangle, has the robot and its computer, the one that it is attached on it. So everything is happening on the edge that time. And we're having events going from the robot to the computer and back and forth. And then we had some software also. We had an MQTT server deployed on that server, and all those messages were sent to some topics on that MQTT message broker. An example of those messages is something like that. We have this is taken from a Mongo, so it is the JSON serialized version of the message, but it's pretty accurate. We have the topic like rebel controller, robot station, awareness is the category of what happened, and we had an event. We also had statuses. And then we have the message part. As you can see, this opens here and closes here. And we have the topic. Now, the message part has also an awareness part. And this is the interesting for me. Like, this is what really happened. The package plays, and we also have a value. Now, the value is helping me to understand which events are connected with each other. Like, started picking a packet and placing a packet to the band needs to have the same ID so that I can count the time between those two. And obviously, you might wonder, okay, why not after a pick wait for a place? And the reason why is that the messages are not necessarily coming in the order that they are actually happening. And as you can see here, we have the publisher, like the device that produced the message. That's not very interesting, actually. And we also have the published at. And this is the UTC timestamp of when that event was actually published. But as you can see here, there is a teeny tiny, almost less than a second difference between those two. So first it happens, and up to a second, maybe more, later, the message gets published. This obviously creates issues, and this is why we have the ID so that we can pair them together. Now, as I said, the reason why I was included in the project was to make it easier for them to follow the processes. And this is the first draft of my work. So what I did was that I created a .NET console application, which was also running on the same machine. This machine is running Ubuntu, and it was picking all those messages. It was saving them locally in a Mongo database, and it was sending them directly to Azure via the Azure IoT Hub. There we had the Stream Analytics job picking up those messages and sending them farther on. Don't worry, we're going to talk a lot about those parts, but for the moment, just keep in mind this process. Instead of needing to VPN to the machine, to SSH to the machine, and to manually read the messages that had arrived on that topic. We had an agent, we had a console application subscribe to those topics on the MQTT message broker, pick those messages and directly send them up. Now, as you can imagine, this works, but it wasn't the smartest things we could do, because we had like an ocean of events. We had really a lot of them, and data into Azure usually doesn't cost that much, but the resources consumed here were quite vast. So we had to find something smarter. And the first thing that we realized was that running the agent on the machine directly isn't very effective, because we don't only have one robot, and I don't want to be installing .NET Frame, .NET, and various Linux computers all the time. So instead, I deployed the application in Docker. And I also moved the database to Docker, a move which proved to be a mistake. But by that time, I could put everything in a Docker Compose file. I could do Docker Compose up, and that was pretty much all of it. It would be up and running. It felt like plug and play. Those are talking localhost with each other. This is talking localhost with the database. Everything is fine. And even the process of me updating the agent was much simpler, because instead of me VPNing and SSHing to the machine and doing git pull, I could just pull the Docker image from a container registry, which I also automated with a pipeline. So everything worked perfect until one day this thing, the Mongo database being run in the Docker container, exploded. As you probably know, there's a limit of how big a volume can be, and this became larger than it was allowed to be, and it just froze. It stopped working. And also, in the same day, not only Docker started complaining, and we lost the connectivity with Mongo, but even the whole computer, the hard disk in the computer, became full, because we were saving, by that time, we were saving the images taken by this mega camera up there, and nobody knew about it. So I was asked to enhance my agent with a function to check the hardware in the machine. And I mean, that's totally fine. I'm already running on the machine. I have all the tools needed to check. But there is a but. This thing is running in Docker, meaning that in my world here, my computer is Docker, which in essence is a virtual machine. So if I'm asking about disk capacities, then I'm not talking about this computer's disk capacities. I'm talking about these virtual machines' disk capacities. And obviously, this is problematic. So what we did was that we created another application which we call the Spy, and this one is built in Node. Now, why Node? Well, because those things are running Linux, and as I said, we don't want to be installing all those frameworks, .NET and everything. It just has to run out of the box, pretty neat, pretty simple. So we install that one. That one can ask the machine how it feels. It can deliver me a heartbreak functionality. It can tell me about the disks and their capacity and the network and pretty much everything, even the sensors and the temperatures. And since it's a node application, it's a server of itself, and it can expose an API endpoint. And this API endpoint has been consumed by the agent. So now the agent is not only subscribing on the MQTT message broker, it is also polling the spy's endpoints, asking about the hardware of the real host. And then it's still deploying everything to Microsoft Azure. And again, everything seems to flow, everything is nice. But one day, Mongo broke again, and that time we couldn't bring it back to life. We had to kill the container and to recreate it. And then we realized that our data is not as safe as we wanted them to be. So what we did is that we introduced another application, which we called the ankle. And the ankle was had only one responsibility, to poll Mongo like once an hour or even less often, to pick all new messages, serialize them in JSON, and send them up to an Azure function. Now, the Azure function itself, you could imagine that it could save all those things to a Cosmos NoSQL database so that we had like a mirroring copy of that thing. But this is pretty useless because we have like 90% of the data there are just logs, and they're only useful if something goes very, very wrong and it's not obvious what happened. So we have to dig in the logs. So to keep things simple and first and foremost to keep them cheap, what we were doing was that we were converting them to blobs. I can see that you can see that, but I have an Azure storage icon behind the AIoT Hub icon here. This is a storage account. So I'm saving the blobs there, and the blobs have a life cycle themselves. So when I first save them, they are in the hot tier. Then a week after that, they move to the cool tier. And a month after that, they move to the cold tier. Oh no, thanks. You moved it away. Thank you. They move to the cold tier. And by that time, they cost like effectively zero. But also, if a week, a month, 2 months have gone and I haven't had need of the log messages, then chances are that I will never need them. Because if something breaks, then we know about it, like if not within an hour, for sure within a day. So it only makes sense to keep them in the hot tier and cheaply accessible for a short period of time. If I remember correctly, after a month, we moved them to archive, which, yeah, as you know, costs pretty much nothing. So, yeah, now I think it's time to focus to a little bit more interesting stuff. But before that, I'm just going to show you like a final image of how we make sure that we never have data loss. Like we have three things. First of all, the agent, while we still are on the edge, is picking the messages and save them to the Mongo database directly. Then secondly, the messages are sent to the Azure IoT Hub, and from there we move them to various other spaces. More about that in a minute. Now, I want to put an asterisk on this sending all the messages because it's not really true. And then, of course, you have the uncle constantly looking to copy everything and make sure that it never disappears again. Now, about that asterisk, I wasn't completely honest with you. We don't really send everything. I think I hinted in the beginning by saying that it is an ocean of data, and sending log messages like now this lamp was on, now this lamp was off, now we had like um, like really non-important data. There is no reason to send all those in real time, and there is most importantly there is no money to spend to process all those things. So what we're doing is that we're pre-processing on the edge, and we only send the processed data to the cloud. So we have a mega computer on the edge, so why not use it, right? We want to use correct tools for correct work. And in my mind, it seems crazy that if I have to do like a simple calculation, that I will do it on the cloud. Now, an example of that calculation for that specific task of depalletizing is the mean time of moving each packet. Now, to calculate that, obviously, you will have to count the time it takes to move each packet, and then you divide it by the number of packets, right? No problem. Now, to be able to do this real time, you have to know when the pallet starts and when the pallet ends. And the key point here is that you don't know when the pallet ends. There is no way to know if there are more packages until you see the empty pallet, or until the conductor pushes the button to signal that now you're done. So all those mean values can be calculated on the edge. And instead of sending every single move of the robot to the cloud, we can just send the interesting numbers, right? And to me, this was a game changer, because suddenly we didn't have any bottlenecks, and we could dramatically decrease the costs. Now, what really interests our operators is process data, of course, but different operators, different stakeholders are interested in this different stuff. So we have the operator, which sees something like that. This is a screenshot taken from the digital twins, which I will show you a bit later. And this one is a screenshot from Power BI. Now, I mentioned before that we're using Grafana, and Grafana is an open source alternative to Power BI. And maybe you're surprised that I'm not advocating for Power BI, but for that project, we really didn't have a lot of motivation to pay the expensive licenses, since we only wanted to visualize quite simple data. And we also wanted to visualize this data to various stakeholders, where not all of them were part of our organization. So as you can see here, we have like quite a level of detail. This is important from the operator, but totally boring and non-interesting for other stakeholders. Like, for example, those who are really paying for the stuff. This is a screenshot from Grafana, and now I apologize for parts of that being in Swedish, but this shows the pickups per hour. And you can see that we have like various numbers here, and we have like the amount of time with a pallet in place. And the green columns here are all the times that we picked the pallet. And the big yellow block here is the time that the robot was idle. Now, why was the robot idle, and why for such a long time? And in that case, the answer is pretty simple: because the factory was closed. They didn't have anything to pick. But in the end of the day, this is a very nice visual way for the stakeholders to directly identify what can be improved. By seeing how much the robotic arm is working, they can make decisions like if it really makes any money where there is, or if it has to be moved somewhere else, and all that stuff. Now, we had the conductor, we had the stakeholder. What's left is me, the nerd. So obviously, we have another Grafana dashboard where we can see all in a more visual way everything that is going on. And this is a very nice example of something being wrong. You see, we have a gap here, and we can see it in every chart. And now I don't remember exactly why this happened, but it's like what you see when you check your heart, and it's pretty easy to recognize the patterns of something being wrong. Now, all this nice project, I believe that it could be done with other resources, even not based in a major cloud provider. But in my opinion, the Azure IoT platform made the whole thing viable. And why do I say that? Because the end architecture looked something like that. We had all the messages arriving to the Azure IoT Hub, and the IoT Hub is like an extension of the Event Hub, the usual Event Hub. And what it is, in essence, is an Event Hub with a lot of IoT functionality. It makes it very easy to register new devices, and to get like connection strings or other stuff, and to use them in your applications that are running on the edge. Now, the Azure IoT Hub itself, just like the Event Hub, doesn't do anything with the messages. The one who does something with the messages is either the Azure function, which is picking up the messages from the event, from the topic here in the IoT Hub, and the Stream Analytics job, which is using the Azure IoT Hub as an input, and then it is moving the data to a Postgres database, which is also deployed in Azure, and then the tables of this Postgres database are used as data sources for Grafana. And of course, it is also moving copies of the messages to a Cosmos database for them to stay there. Now, the choice of tools has been particularly important for many reasons. Like if we take the IoT Hub, first of all, we have the message-based architecture, which is exactly what we need. We need to decouple those things because I cannot count on the robot being live, being on for me to pick the messages. I have to send them directly, and I don't want to process them on the minute they arrive. Maybe I want to wait. Maybe I want to do something else with them. Then the fact that I can register devices and it's a pretty much plug and play thing makes the whole project much more viable because I can keep the short lead times, and there are like integrations with a number of resources in Azure where Stream Analytics is just one of them. And there are like SDKs for to send data to the Azure IoT Hub. Like I used it with C#, but I know that there is a JavaScript version as well. There is for many languages. Then we have the Stream Analytics jobs, and I will show you them in just 1 minute. Now, those are very interesting for many reasons, but the most important one, in my opinion, is the fact that they can pause and rewind. So what the Stream Analytics job is doing is that it has an input, it has a query, and it has an output. So the input in my case is the IoT Hub. This is where the messages arrive. And the output is all the tables in my Postgres database. Now, in which table its message goes is defined in the query. And if something goes wrong, if the message is malformed, if the Postgres database is not up and running, then it just waits. And if I have to change something and try again, then I can rewind. I can ask it to start the whole process again, to pick all the messages again from a certain point in the past until now. Now, of course, I urge you to be careful with that because we are going to have duplicates, right? So I did use that in cases that I had truncated the whole table and had to rewrite everything again. And now we have seen creating the data, sending it to, oh my God, my mouse just died. I will have to connect it to the cable. Let's see if it helps. Of course, it happens live on the presentation. Good, I'm up and running again. Now, what I was saying is that we have created the data. We have processed the data. Now, it makes no sense unless we can display the data. And I explained why I didn't choose Power BI, but I didn't explain why I chose Grafana. And Grafana gives me an easy access control. I can use the usual app registration to give access to my whole tenant, like a usual SSO where users can connect with their own email addresses, the very ones that they're using for the rest of their Office 365 things. And there is like a wide plethora of presentation tools. You can do magical stuff. I believe that data scientists are going crazy. And the last thing, the one that I saved for the end of the presentation, is the digital twins. Now, it's better that I show you before I explain you, but the reason why we need a digital twin is that we have to display things. that have a call to action. Like if we have a sensor telling us that something on the robotic arm is hot, and we get this information, and someone in one part of the country has to call a technician on the other part of the country and explain them that this is behind the gear, and not the red cable, the green cable, and all that stuff. As you can imagine, this is going to be a disaster. So we are using digital twins for that, and you will understand directly in the demo that I will show you. Just before the demo, this is a starter pack for Azure Digital Twins. It is one that I had a big difficulty finding online, some documentation. This is how you get it started. So you create your models using the DTDL, the Digital Twin Definition Language, which is like a box in a box, in essence, architecture. You have like on the top one node, and then you have other nodes that have that first node as a parent, and after them other nodes. It's like a tree structure, right? Then you create your twin by importing some dummy data. I used Excel actually, but you have to keep this tree structure that you registered before. Then to make this thing visual, you can use GLB or GLTF files, and you can connect the parts of your components with your twins and build behaviors based on that. Now it will be much easier for me to show you those nice things. Let me zoom in a little bit. I hope this is visible now. This is an Azure Digital Twins instance. So if we go here, it's only connected with storage, where we storage account where we save all those stuff. The digital twins are going in a table, and the files are going in a container. And we also have an event topic where the functions are sending their events to. Now let's see what I have here. If I run the query, select everything from digital twins. Yep, up here I have the Rebel Industries. This is like the parent node, the one that rules them all. Under that, I have either the lab or a customer, any customer. And then I have my robots. Adam is in the lab, while Black Panther is in a customer. Now, if I click in any node, then you can see here in the right part the twin properties appear. And for this one, I don't have any properties. Only name. This as well, only name. Here I have a bit more. Here I have the status being run. And I
Nikos,
also,
it's a bit small. Could you make it larger for us?
absolutely, yeah.
Thank you.
I hope it's better now. Very good. So here I have some more interesting properties, and those are all declared in that Excel file that I told you earlier about. So I have a name property being a string and a status being a string, and I also have one status integer. Now the only reason why this is an integer is because I can direct my behaviors based on integers better than based on strings, right? And then you can see that I have an organization which is of type rebel org. I have a robot which is a rebel robot, and I have the farm, which is the whole thing, called rebel farm. Now this is quite boring, and I know that you expect me to show you something fancier, and here it comes. This is the studio of the digital twins, and I have a 3D scene. I have already uploaded a file like that, the ones that I mentioned earlier, a GLB file. Now, as you can see, I can turn this thing around and show you exactly what it's doing. It shows exactly what the robot is doing, not in real time, obviously. And right now, we are in build mode. So I am designing my behaviors. And as I hover over the various parts of the robot, as you can see, I can focus on each one of them, and I can click on that, and I can edit the element. And the mess here is the parts of the element I clicked, and I can add a behavior on it, like the one that I have here to change color by status. Now, do you remember this one? Based on the value of this one, I will change the color of the whole element. If I click on it and then edit, then as you can see, what it says is that it has a visual rule which actually is going to turn this thing to green if the value status int, again, status int for integer, is between 1 and infinity, and from minus infinity until 0.9, then it will be red. Now, if we leave the build view and we go to the view, then as you can see, this is already green. Now, let's see if I can make this thing a little bit. Yeah, that's pretty decent. Now, if I change this one to 0 and I save here, okay, I got a confirmation, and it will need a very short amount of time to turn this thing to 0. There it goes directly. If I make this 1 again and I save, then quite fast it will turn green. So as you can imagine, there is no reason for someone being here changing the values to see how this works, but all those properties are available in the twin, which is operable by the SDK. So I don't have a person being here changing those values, but those values are changing by the agent. This is the one which sends all the signals to the digital twin, and then this thing is displayed in big screens in the factory so that people that are working there can see exactly what is happening. And if something is like blazing hot, then we can zoom in. We can zoom in to the very part itself. Now imagine that this little code here could be very red, and the operators can pause and understand exactly what they need to change. Now, this thing, I can't imagine how it can happen in any other way. Imagine that those things could be in the middle of the ocean, it could be like in the middle of the desert, it could be anywhere. And this gives us the possibility to operate them without having a real image of them. Now, before going to your questions, if there are any, I just wanted to show you the stream analytics job as well. And as I told you, it has three main concepts. It has the inputs, which in my case is the IoT robot farm. It has the outputs, which are all those tables in Postgres. And I have the query. Now, if you have multiple outputs, as I do, then soon enough you will have issues with your computing power, because it will take ages to load. Oh, like it did right now for some reason. Let's refresh it. Okay, now here we got it. Now the thing is that this runs an embryo of SQL. So if we run this every single time for the robot Adam, and then for the other robot, and then for the other robot, and then for the other robot, then what is happening is that it is processing the message once every time we do this. Now, I don't want this. I want the message to be read just once and then to run my logic. So what I do is I'm using a with statement, and I pick the messages of this session, of this running. I put everything in input, and then all the other queries are not going to the IoT hub. They're going to the in-memory data set that I called input. As you can see right here, everything is from input, all of them. And as you can see, I have a large number of them. and each one is sending to a different table. Um, yeah, another last interesting part about it is how this thing scales. It has a fantastic automatic scale rule set. And in my case, I have configured it like that if either the resource utilization, like the memory or the CPU power or the watermark delay is the time between a message coming in and the message coming out, surpass a certain value, then I beef it up. I increase the computing power of the whole stream analytics job. And when all of those, both the memory and the processor power and the watermark delay, fall under the allowed limits, then I take it back again. And obviously, it costs less and less and less. Now, I think that that was all I had, and I am open for questions.
Cool. Thanks, Nikos. That's absolutely fantastic. I
Thank
had a
you.
few questions. If anyone else has got any questions, please put them in the chat and we can ask Nikos live. So thanks for sharing all the learnings and, as we know, admitting the things that didn't go well as well as the things that did go well. A great example of edge computing. Why was you said that the box by the robot had a lot of heavy duty processing power? Why was that? Because generally, I mean, even if it's doing image recognition, it's quite low, could be low powered unless you're actually training those models at the edge.
Yeah, the thing is that it's not simple image recognition. It using point clouds, so it's not like a usual camera taking a photo. It sends infrared beams, expecting them to come back because it's not only where, like in X and Y, the packet is. The robot also has to know how deep it will dive to take it without crushing it. So it identifies in a 3D world where its packet is, and this is
Right.
pretty heavy activity. Then
Okay.
it's not only that it has a lot of other stuff going on with other sensors. Yeah, it has quite a lot to do.
Cool. And one thing that's always fascinated me is the regression testing of something. So, you've got your robot and it can move around and then says, oh, can we just make this small change? How do you
Hmm.
know that small change hasn't affected some edge case over here that then breaks its functionality? How do you regression test an arm?
Yeah, well, they have one in the lab always, but as you very correctly say, when I was building the agent, I was dependent on the arm being in action, picking stuff. Otherwise, I didn't have any messages. So what I did was that I asked the team in the lab to make a full circle to run like the robotic arm for an hour or so, and I collect all those messages and I put them in an emulator that was sending the messages again and again and again in my own message broker locally on my machine and in the intervals that they were sent in real time, in real life. So this is how this was automated. And again, okay, it only plays one scenario, but it was quite a lot of job just to make the happy paths
Yeah.
work. Yeah.
So it sounds like your involvement in the project was the processing of events and the
Yeah.
cloud processing side. You may not be able to answer this question. How to deal with edge cases like packages ripping? So it sucks on a pack, then the pack
Yeah.
rips, but it's still going up.
Well,
All
this is
those kind of things.
I think that they discovered all those in the training phase, which for the first project was like 3 months or something, and everything imaginable happened. Like they had the robot crushing packets, or they had the robot dropping packets, or they had packets with liquid content that make it impossible to pick. And then what happens is that the robot makes a try, and sometimes it just says, "I'm sorry, I cannot pick that up." And then it gets read in the digital twin so that the operators can go and handle this by themselves. The more interesting for me edge cases is when someone pulls the plug, and then I have collected like a pick packets, but I never get the place packets. So what I have in my process there is that I have timers for everything. So if an hour goes, I know that this process takes max 15 minutes. If an hour goes and I never get the pallet done message, then I assume that the pallet is done and I manually mark it as done. Then this whole thing is marked as like something is suspicious, like this might be wrong, and it's being analyzed by the people in the lab. And then I don't really know what they do in practice, but I guess that they have an error margin with the client as well, so that some amount of errors are acceptable, and in the end of the day they just want to do as good as it can. There is no need for total perfection.
Okay, cool. Do you do okay? Love the uncle. I love the uncle too. But I must have
Thank you.
phased out when you were describing what the uncle did. Can you just briefly describe
Yeah,
that?
well, the uncle makes sure that the nephew doesn't work without breaking anything, and the nephew is the agent in that time.
Okay, hence the name
Yeah.
uncle. Got you. Also,
Mhm.
from Do okay, why did you choose Azure? Is there anyone responsible of the robot on the, I assume she means the other side?
Yeah, well, I choose Azure because this is my tech stack. This is what I knew, and this is where I found all those IoT tools that made my life much, much easier. Like the Azure IoT Hub pretty much mm, removed the need for me to build a server application on the cloud. Everything was there. I just had to use it. And if there's anyone responsible of the robot on the side, like on the edge, I guess, yeah, no, actually. No, no people from Rebel are at the client. If needed, then they are driving there or flying there. But there is a short period in the beginning of the project, like, I don't know, a few weeks, when they maybe have someone being there on site for a short period. But after that, it works by itself, like a consultant.
Cool. And I'm a fan of 24 and with Jack Bauer. And in there, you've got some great animations of like the computer systems. And I'm just going, someone spent 15 weeks developing that user interface for that complicated system it's got. And that's kind of how I view digital twins. They're kind of a nice to have, and they're not really adding a huge lot of value to the whole process. How do you see the value or proposition of digital twins?
I see that if misused, then they can be a huge overkill and they might even confuse people. But if used correctly, then they're real lifesavers. And in our case, being able to display exactly which part of the robotic arm is malfunctioning is really really important, because there is no other way to explain over telephone. And we are those things, maybe you realized it from the video as well, we are in really loud places in the middle of a factory. It can be dusty, there is a lot going on. You can't do those things over Teams, and you don't always have the possibility to send someone there. So it is the best way we had to visualize the messages we wanted to see to send. And it's not always that something is broken. Sometimes we don't only have the green and red, we have the gauges. Like we can show that it is performing that many packets per hour, and it's placed somewhere in the middle of the facility so that everybody can see what it's doing. Yeah, I think that in the for the correct cases, they're very very good tools.
Mhm.
Yeah.
Okay, great. So, final question. So, if there's any more questions out there, please get them in quickly. Otherwise, we'll wrap it up. Um, has the customer done a cost benefit analysis of the work that's been done here?
I'm sorry, if the customer has what?
Done a cost benefit analysis. So, has it saved them lots of money by doing this project?
Well, I'm pretty sure that there are like major savings because the machines work 24/7 right there, and then those robotic arms are deployed to do jobs that are in Sweden are people aren't allowed to do them after a period of time because it breaks your back. It's like bad for the human body. Those are really heavy. They're dull tasks that humans don't want to do. Yeah, so I don't have any numbers, but I hear that the customers are excited.
Well, okay, that must be a good thing then.
Yeah.
Okay, great. So unfortunately, Paul didn't join us to tell us about the next event. It will be on the 12th of February in London. We will record it. It won't be live streamed. We had problems live streaming in-person event last year. So we're not going to do that again. Great Swedish there, Thomas. So hopefully we'll see there more details on the IoT London meetup website, and we'll send the emails out as appropriate. And thanks very much, Nikos. It's been great having you.
Thanks for having me.
Very interesting talk.
Thank you.
Okay, so I just need to press the right buttons now. Okay.
Yeah.